Hi everyone, in this video we will focus item 5 in effective Java, which is really important item. In item 5, Bloch says prefer dependency injection to hardwiring resources. I believe you already heard about dependency injection, dependency inversion principle, and other solid principle which is included what I will talk about in this video. I believe you're already aware of this solid principle because during this video, while I will explain this item, I will touch all the time solid principle, which is really important to understand the concept. But in this item, he basically mentions something very, very important. In appropriate or static utility class in flexible and untestable. If you go down, you will see one bold text. Static utility classes and singletons are inappropriate for classes whose behavior is parameterized by an underlying resources. So what does it mean, this sentence? This sentence means basically if you force something to singleton, which means you depends on instance that you created in a singleton way. He has a very nice example in here. Let's see, there's a spell checker and it forces to singleton in this example what it means, and you are fully depends on lexion dictionary. You are not flexible between dictionaries. This is not flexible and this is not testable. If you remember in item 3 we investigated lazy cache, enum cache, and eager cache. Also, we enforce everything to the singleton in that item, and what happened at the end, you cannot work any other cache. You cannot change your cache mechanism. If you create your instance in the eager cache, you really depend on the eager cache. In this item, Bloch says prefer dependency injection to hardwired resources. So this is very simple. Also, in solid principle, the D letter, we are talking about dependency inversion principle. So dependency inversion principle means do not depend on concrete class, depends on abstract classes. Because if you are dependent on abstract classes, what are the abstract classes? Is abstract class of interfaces. If you depend on them, which means you can be the couple between the components, and you can change the components when you want to use them. I will talk about it deeply, but don't forget, dependency inversion is not the same with dependency injection. Dependency injection is implementation of dependency inversion principle. Dependency inversion is a philosophy. So let's go back to our first example. This is the example that I really like and which was taught me by my mentor in the past. And I really like this example to understand this concept. Basically, what is wrong with this code? There is nothing wrong, right? You have only one print line and you are printing to the console hello world, which is very simple. So there is nothing wrong. Do you think there is nothing wrong? No, there are some things wrong. If you start to think about it deeply, you will see backgrounds. And the thing is, in here, you are not flexible. What happens if you need to change message? Let's say, hello effective Java item 5. What did we do now? We changed the message and we need to recompile our application class. Let's recompile it. And now we can see that message, hello effective Java item 5. Another way around, how can we make it better? Question is very simple. How can we make it better? Actually, there's one way. We can make it more flexible. How can we make it more flexible? If I receive messages as an argument, I can print them, right? If arguments bigger than 0, iterate each item and print it. Or print a default message, which is hello world. Let's test it. How can we test it? I will come here and basically Java application Java, and I will give a message. Let's say hello world from hello effective Java world, hello effective Java world. If you run it, you will see hello effective Java world. If you run directly java.application Java, you will see hello world. This code absolutely is better than the previous version because it's more flexible. We can print whatever we want. So if you see the flexibility in here, I can change the messages. However, there are problems. There is a two different problem. We are giving two responsibility to application class. First, rendering the message, printing the message, and providing the message. What do I mean? So how do we print the message? How do we render the message? We are rendering the message in that part, system.out.println, right? We are printing the message. We are providing the message in here, and also we are providing the message in arguments. So we have two different responsibility for application class. An application class definitely violates solid principle, because first rule of the solid principle says single responsibility. Do we have single responsibility in here? Of course not. We don't have it. How can we make it better? We can give responsibilities to different class. And giving the responsibility to different class means we can create default message provider, which keeps the message, as you can see in here, get message. Another one is standard output renderer, which will receive a message provider and get the message and print the message. If I go back to my application in this example, what I will see, I am creating default message provider instance, and then I am creating standard output renderer instance, and I am setting my provider. This is what we call dependency injection. This is actually setter injection, because we have three types of different injection: field injection, setter injection, and constructor injection that we are using right now. Setter injection, what we are doing, we are giving our provider and then rendering the message. Let's go back to default message provider. What message do I have in here? Default message, right? Let's go back to standard output renderer. I have two functions: set log provider, which receives the default message provider, and render the message by calling message from the default log provider. If I run this, what I will see in my console, I will see basically, well, I don't see anything. I should have seen something because we didn't render the message. Sorry. Yeah, I will see default message. If I go back to default message provider, what I will see, default message provider, let's say hello world from effective Java. Anyway, message is not important, right? If I run it, I will see that. So do you think we are flexible than before? We are more flexible than before, right? Absolutely, we are more flexible than before, because we divide the responsibilities, we separate the responsibilities into two different classes. One is responsible to provide the message, other class is responsible to render the message. We are more flexible. However, we have still a problem. Biggest problem is we are still dependent on only one message. We need to extend it. And the second problem is, which is very important, what we mentioned in the beginning, and also dependency inversion principle, do not depend on concrete, depends on abstraction. And now, if you see in here, application class knows only concrete classes, standard output renderer and default message provider, which means we are fully tight coupled to these two classes, and we need to make them flexible, and we should depend on abstract classes, not the concrete classes. How can we make it? Of course, in the fourth example, we need to create interfaces, which is message provider interface, which will be extended by our provider classes, right? This interface has three different functions. Get message formats, because each provider might have different formats, right? Set message. In that way, we are also giving the flexibility of the client. They can set the message they want. And get the message. If you go to implementation of the message provider, Telegram message provider implementation, which has the Telegram format and setting the message, also it has a default message, and it has get message function. If you go WhatsApp message provider has its own format, it has the default message, and it has get message function, because both are implemented by message provider. if you go to render, you will see the render interface, which has render function and set message provider function, which will enable setter injection, dependency injection. If you go to error output renderer, what you will see, error when we are rendering, if it's error output renderer, it will print the message with a red color in here, and we will receive the format from our message provider. This is our setter injection message provider, and we will print the message with red color, proper format, and the message. So this is very flexible. If you go standard output renderer, it uses a blue color, and it also print the message with a format, color, and given provider. If I go back to my application in example 4, what I will see, as you can see in here, application class, left side of my application class depends on abstraction, because application class only knows message renderer and message provider. Both are a factory class. On the right side depends on concretes, because I am still have a responsibility in here, and this responsibility instance creation. We will come that. And then I am setting the message, for instance, hello from Telegram, and I'm doing injection in here, set injections, set message provider, and I am rendering the message. If I run this application, what I will see, I will see Telegram, hello from Telegram, because it's Telegram. How can it be more flexible? If I want to work with the WhatsApp message provider, I will just create instance of the WhatsApp message provider, because WhatsApp message provider is already a provider, right? It's already a message provider. And if I want to change the message, hello from WhatsApp, what I will see, hello from WhatsApp, and with the WhatsApp format in blue color. I am also flexible in message render, right? I have two different message renderer. If I want to work with error output message renderer, if I create instance of the error message renderer, if I run this, what I will see is a red color in the console. So which means I am very flexible between the components. I'm not tight coupled to them. I can easily switch between the providers and renders, because they depends on abstraction, and both, like WhatsApp message provider is a message provider, Telegram message provider is a message provider. In the future, email message provider will be a message provider, or I don't know, like Berat message provider will be the message provider. Also, X or Lau output renderer or Valentine's output renderer will be the message renderer. So which means I am very much flexible in the components. And that's why George Bloch mentioned you need to enforce your classes dependency injection. Please prefer the dependency injection to have flexible, testable applications. This is very important. However, we have a still problem in here. What is the problem? This little bit goes outside of the dependency injection, because dependency injection starts in here. You can also force these classes to have constructor injection. How? If I go back to my error output renderer, if I set this public error output renderer, right? Sorry, this dot a message provider. I will receive a message provider from the constructor block of my from parameter, and then I will set this. And also I should be flexible to create without having any constructor. If I go back to my application in here, I will remove that one. And I will just put it one line after message provider, and I will set my message provider in here. And what will happen? I prefer dependency injection with constructor injection in that part. This is the constructor injection. You can also use field injection. Both are possible, but now I use two-way. Anyway, problem. So if you look at the code, we have a problem in application. Application has one more responsibility. We already give the two different responsibility to different classes. What kind of responsibilities? Rendering and providing message, right? Application only responsible to call these classes. However, in that point, application is responsible of object creation. This is not something that we want, because we want to separate responsibilities based on solid principle. And also, I am still depends on something. Like, imagine what I want to do. Some part I want to use. Let's say I did this, right. I always use WhatsApp message provider with error output renderer, or let's standard output renderer everywhere. And then they told us we need to change our provider. It should be email. Oh my goodness, how many places that I created new? Maybe 100, maybe 200. You have to go 200 places and need to change WhatsApp message provider from WhatsApp message provider to Telegram message provider or email message provider. So which means this needs a lot of work, and that's why we need to give responsibility of object creation to another class. And in that point, factory, you need to consider factory pattern, abstract factory pattern. But the thing that I implemented is not fully abstract factory pattern. I'm trying to make it easier and understandable as much as I can. That's why I implement in a different way. So I have a factory interface in here, and this interface has one function, create instance, and it receives a generic T. And I implemented this interface in two different classes, which is render factory class, and I forced my render factory class to a singleton. How I force it? First, I create a eager initialization, right? And then there's a private constructor block, which means we cannot create instance of the render factory class outside of the scope, outside of the class. And then I had the get instance function, which can be accessible directly because it's static. And also I overrided my render create instance. As you can see, I am creating error output renderer instance in here. And also I have provider factory. This is exactly the same that I have in the render factory, and it only creates WhatsApp message provider. So if I go back to my application, now my application only knows abstract classes. It doesn't know anything about which provider is or which renderer I am using it. Right. So this is very, very important to understand the concept. What I am doing in here, I am calling render factory.getInstance, provider factory.getInstance, and now I am calling create instance message renderer, create instance of provider factory, and I am setting my provider and rendering the message what I want. And if I declare this 100 place, in some point they say, okay, we want to switch from WhatsApp provider to Telegram provider. What I need to do, I need to only change to one place. So which means I separate the concerns from each other's responsibilities are in a different class, give it responsibility to a different class, and I am very flexible between the components. None of them tight coupled each other, all of them are loose coupled. And the biggest advantage is that I am providing the dependency injection in here. This is a setter injection. This is the main point that the George Bloch mentioned in item 5, and it's very crucial to understand. I hope this video is very helpful for you to understand this point. Of course, today's we are using IOC containers like Spring Boot or Spring Framework, let's say. And we are flexible to inject our classes using auto-wired annotation. This already deprecated. Spring community doesn't recommend it anymore, by the way, so you shouldn't use it. You should use a requirement argument constructor which comes from the Lombok, or you can, when you define a class as a service annotation or component annotation, it will be injected by Spring Boot automatically to your constructor or setter or field. So those things are very important to understand the concept. Of course, we are not writing our own IFC containers anymore. We are using the frameworks. We are giving these responsibilities to frameworks. We should give these responsibilities to these frameworks because we shouldn't trust our own implementation, even though you are the best developer, but it needs to be tested many times. And also, we should build product which is future friendly, right? And we cannot think about every single case by ourselves. We need a community who already taught these cases for us, and we can use what they built. So that's why it's not important to build. I mean, you won't build your IFC container, but it's really crucial to understand how things work under the hood and how can you make things better. This is all. Thank you very much for listening. Have a nice day.